Picture this, okay? It's Black Friday, literally the biggest sales day of the entire year. Your retail store managers are frantically running critical reports to track hourly flash sales across, say, 500 locations. They desperately need real-time data to make split-second inventory decisions, so they click a single slicer on their Power BI dashboard and absolutely nothing happens.
Instead of getting those instant insights, they're just staring at a spinning loading wheel. And that visceral, stomach-dropping frustration builds for exactly 45 seconds. Then, the ultimate nightmare. The entire system just crashes with a fatal out-of-memory error. Does that sound at all familiar? Well, welcome back, and to this special Masterclass edition of our Explainer. Today, we're moving way past the basic tutorials to upgrade your skills straight to enterprise-level analytics.
So let's just dive right into the big question. Why exactly do these dashboards fail at scale? You know, when you're dealing with millions of point-of-sale transactions, complex product hierarchies, and incredibly fast-moving inventory, basic Power BI design completely falls apart. You really can't just load in flat files and cross your fingers. You absolutely need an architecture that scales. To get us there, here is the roadmap for today's explainer. 1. The scaling problem. 2. Building the Star Schema. 3. Optimizing DAX formulas. 4. Market basket analysis. And finally, number 5, auditing for performance. Let's get to work.
Starting with part 1, the scaling problem. Step 1 is simply identifying the root cause behind that dreaded spinning looting wheel. And I'll tell you right now, it almost always starts at the foundational layer, which is your data model.
There's a really stark contrast in how you can build this out. A super common mistake in retail reporting is trying to mimic a transactional SQL database by using a deeply nested, multi-hop structure, what we call a snowflake schema. You've got a table for a category, which filters a subcategory, which filters a product, which finally connects to sales. It just forces Power BI to evaluate multiple relationship leaps every single time someone clicks a filter. What we actually want is the highly efficient, clean, one-way relationships of a star schema. Which brings us to part 2, building the star schema. Let's talk about how to structurally fix a messy model by diving straight into Power Query and doing some serious de-normalization. Here are the exact steps to build that lightning-fast foundation. First up, we're going to merge our product, subcategory, and category tables all together to create one single clean dimension table. Next, we drop our heavy transactional data, so the sales and inventory fact tables, right into the center of the model. Then we just surround them with our dimension tables like product, date, store, and customer. Now, the absolute crucial rule of engagement here, relationships must be strictly one-to-many, and the filter direction has to flow one way, straight from the dimensions down to the facts. And a massive, massive warning for you, never use bi-directional cross-filtering on your fact tables. Just don't do it. It allows filters to flow backward, creating huge performance bottlenecks and totally unpredictable calculation errors.
All right, part 3, optimizing DAX formulas. Our data model foundation is rock solid now, so we're moving up a layer to the calculation engine. Because unoptimized DAX forces the system to literally scan millions of rows line by line, completely killing responsiveness. We've got to fix that. In retail, calculating year-over-year sales growth is pretty much standard issue. But if your DAX is relying on an iterative filter over, say, 10 million rows just to find last year's data, your visuals are going to lag severely. So, by defining a variable using var, we evaluate our current sales metrics exactly once, and we store that result straight into memory. Then we leverage the calculate function alongside built-in time intelligence like same period last year. This basically tells the underlying engine to just use the date index directly. Do this, and you'll see your visual load times drop from painful seconds down to instant milliseconds. It's a total game changer. Now, this really beautifully illustrates advanced evaluation context at work, especially when you're dealing with complex metrics like the inventory turnover ratio. Operations needs this ratio to know exactly how fast we're selling and replacing stock. To get it right, dividing cost of goods sold by average inventory value, we have to use average X. This is a powerhouse function. It calculates the inventory value at the end of each day or week, and then dynamically averages those values out over whatever time frame the user selects on their slicer. It could be a single month or an entire fiscal year. The function just adapts perfectly.
Moving into part 4, market basket analysis. We are tackling one of the most requested and honestly, traditionally most complex features in retail analytics. Executives always want to know the answer to this. When customers buy product A, what else are they throwing in their shopping cart? The thing is, if you try to solve this using standard table relationships, you're going to hit a brick wall. Selecting product A on a slicer will just automatically filter the entire model to only show product A. That makes it completely impossible to see what other products were in that exact same transaction. So the highly counterintuitive trick here is actually using a disconnected table. Step 1, we create a table, let's call it filter product, that has absolutely zero physical relationship lines connecting it to our sales data. It's totally independent. Step 2, we write a DAX measure to extract the transaction IDs tied to the product selected on our new disconnected slicer. And finally, step 3, we bring in the treat as function to dynamically inject those transaction IDs back into our primary sales table as a filter context.
What this does is it bypasses standard filtering entirely and forces the report to display all the other items that share those identical transaction IDs. Just think about the clarity this gives you. Now, your category managers can instantly see that when customers buy a high-end coffee maker, 80% of them are also buying a specific brand of organic coffee beans during that exact same checkout session. That is incredible, highly actionable intelligence, all unlocked by just a bit of clever DAX architecture.
Finally, part 5, auditing for performance. We've built an amazing dashboard, right? But before you even think about publishing this to the cloud, you absolutely must rigorously audit its performance to ensure that 45-second spinning wheel is gone for good.
First thing you do is fire up the Power BI Performance Analyzer to track your DAX query times versus visual display load times. If your query times are still high, you need to go back and rewrite those measures using the variable caching techniques we just talked about. But if your actual file size is bloating, you'll want to use an external tool called DAX Studio to check column cardinality. Massive transactional timestamp columns, they are absolute performance killers. A column tracking exact dates down to the millisecond is going to create millions of unique values, which completely blocks data compression by the VertiPack engine. The fix is actually super easy. Jump into Power Query and just split that single timestamp into one clean date column and one separate hourly time column. The sheer magnitude of that one simple change is honestly staggering. Just by splitting those exact date timestamps into separate columns, you can instantly slash your total file size by up to 80%. 80%! It dramatically lowers the memory footprint and just supercharges your dashboard speed. Which brings us to our final thought for this explainer. Does your dashboard rely on flashy visuals, or does it have a lightning-fast, scalable architecture that stays completely stable under heavy user concurrency? Because true enterprise analytics is all about that foundation. I really want you to test this out for yourself. If this masterclass helped you get a better grip on data modeling and DAX optimization, be sure to hit that like button, subscribe for more advanced business intelligence content, and leave a comment down below letting us know exactly how much file size you saved by splitting those date time columns. Thanks so much for joining us for this explainer, and keep optimizing.